All right, guys, hope you're enjoying your self-quarantining. We're going to go ahead and talk about exponentials and logs today. So, as we take a look, I thought a good place to introduce things was we're going to go ahead and it says complete the following table and graph f of x equals 2 to the power of x. Mostly I just want you to graph it, but I think a good way to do that is think about the table. I usually start at the middle of the table because most people know 2 to the 0 power is always equal to 1. 2 to the first is equal to 2. 2 squared is equal to 4, 2 to the third is equal to 8. As for negative exponents, it's 2 to the negative 1 is the same as 1 over 2 to the first. So you get 1/2. So 2 to the negative 2 is 1 over 2 squared. You get a 4th. So what do you think you get for the last one? An 8th. So notice it has a relationship with the bottom part of the chart, but it's like just in the fractional format. Okay, so let's go ahead and let's plot these points then. Let's see what it looks like. You'll notice it's curving up, and on the left side it gets closer and closer to the x-axis. So if we connect these points, our graph looks like this. So the domain is all real numbers. It'll go all the way to the left and all the way to the right. However, our range is limited. It does not go all the way down. The smallest it goes is 0. Does it actually ever touch 0 or obtain a value of 0? No, so we use a parenthesis, and it goes to infinity. Whereas the asymptote is along that y-axis, x-axis, so it's the line y equals 0. Okay, as we think about the inverse, we're going to flip-flop our x and y's. I think that's the way most of you guys were most successful with it last unit. So let's flip-flop those x's and y's. And once you've done that, I think you're pretty good at then graphing the points and seeing what it looks like. So we end up with something that looks like this. Notice that is a reflection of that line y equals x. It does have a relationship with the graph on the left. Since we know it is an inverse, the domain and range should flip-flop. So the new domain is now 0 to infinity, which was the range of our exponential graph. And the new range is that negative infinity to infinity. If you need some convincing, take a look at the graph. It doesn't go all the way to the left. Notice how it stops at 0, but it does go all the way to the right, so infinity. As for the range, it does go all the way down and up, so therefore negative infinity to infinity. Here our asymptote has switched to x equals 0. What I'd like to point out with this graph is technically what we've just done over here on the left is our log. Specifically, since we graphed 2 to the x, it's log base 2 of x. But log is simply the inverse of an exponential. Okay, as we look at this bottom part, this is just defining things for you. So when it says 5 to the third, we're saying, hey, that is equivalent to 5 times 5 times 5, which is 125. So repeated multiplication is kind of our definition of having a base with an exponent. If you've got this fractional exponent, that's the same as saying the fourth root of 16. So what times itself 4 times gives us 16? The answer is 2. Notice here we do want it to be positive or greater than 0 because our n is even, right? That does make a difference. We don't like things that are imaginary. And so we're saying, hey, 2 to the 4th equals 16. On this next step, we're saying the third root, or the cube root of negative 8. The cube root of negative 8 is equal to negative 2, saying negative 2 to the third is equal to negative 8. This one doesn't matter, because in this case, n is odd. As we look at these next one, and when you've got a fractional exponent, but it's got 2 different powers, we're saying, hey, it is 8 squared raised to the 1/3, or sometimes it's easier to say 8 to the 1/3 squared. So then we're saying, okay, what's the cube root of 8? It's 2. 2 squared is equal to 4. We do call all of these exponentials functions. So it's of that form like where you got a base to some exponent. If we have something that is greater than 1, then we call it growth. meaning it's getting bigger. It's the graph that kind of curves up. Whereas decay is the opposite, it will curve down. And notice here, rather than it being negative, it's going to be between 0 and 1. Okay, let's look at the next page. We're going to solve a few of these. So this time it's asking us to solve it by rewriting with a common base. So here, we've got a base of 2. So we're basically going to leave the left side alone, and we're going to say, okay, 2 to what power equals 1/16? 2 to the 4 is equal to 16, and to make it a fraction, we're going to make it a -4. Once you've done that, we're basically saying, okay, well, if the base is the same, then the exponents must be equal. So here we get x equals -4. On the next one, think about the same thing. We've got a base of 3. We can leave the left side alone, but 3 to what power equals 27? We get a third again. Or 3, sorry, again. So if the base is the same, we can cross those out and we get the same exponents. So x equals 4 is our answer. Sorry, I took a step there of adding 1 to both sides as well. Okay. I'm going to do one more, and then I'll tell you the answer for the last one. So on this next one, the tricky part here is I've got 4 and I've got 8. But 4 squared is 16. There's no power that I can raise 4 to and get 8. So maybe there's another base. Let me give you a hint. A base of 2. 2 to what power is 4? Well, 2 squared is. And 2 to what power is 8? To the third. Okay, so then we're still going to leave the same exponents that we already had as well. And then you may remember some exponent rules about how these now multiply. So you will want to distribute it. So if it makes sense, put that in parentheses for you so remember. But we get 2 times 7x is 14x. 3 times 4 is 12. 3 times -2 is -6x. So now solve for x. I added 6 to both sides. X, and then I'm going to divide by 20. So x equals 12/20, which is equal to 3/5, or 0.6. Those are all equivalent answers. Here I'm okay if you write it as a decimal because it does terminate. But be careful, like on the next one, it's not as pretty, so I probably would leave it as a fraction. This next one I'm going to make you do on your own, but if you do the work correctly, you should get x equals -2/11. All right, stay tuned for the next part as we take a look at log.